3D Assist software lets you generate 3D image data on your computer using video files taken with an IPLEX video borescope. This video shows you how to use 3D Assist software. Preparation. This section shows you the steps to use 3D Assist software for the first time. First, download the 3D Assist software from the Evident website. Save the downloaded file in your PC's internal storage. This table shows the recommended PC specifications to operate the 3D Assist software. The downloaded file is in compressed zip format, so please extract it to any folder on your PC. After the file is unzipped, please do not delete, move, or rename any file or folders in the extracted folder, or the software will not work properly. The next step is to authenticate the IPLEX video borescope to be used with this software. First, start the 3D Assist software. When this screen is displayed, click the Setting button and then click the License button. Then click the Registration button. Enter the information of the IPLEX video borescope that you will use with this software. Input the information listed in the Authenticate of Key Code form. Once all the information is filled, click the Activation button. If the authentication is successfully done, the authenticated IPLEX video borescope will be displayed in this table. All the preparation is now complete. The 3D Assist software allows device authentication on multiple PCs with one license. Repeat the above steps on each PC that you will use. 3D image generation. This section explains how to generate 3D images from borescope videos with the 3D Assist software. First, save the video taken with an IPLEX video borescope authenticated by the 3D Assist software, along with an automatically generated still image to the same location on your PC. Please note that the file name of the video and the still image must be the same. Start the 3D Assist software. Drag and drop the AVI or MPEG-4 file on the screen to load the video file into the software. The video file can also be loaded by clicking the Open File button. After loading the video file, this pop-up menu will be displayed. Graphic information is visual data displayed over the captured image, such as text or logo. Select Yes if the video includes graphic information, or No if it does not. Play the video and select the point where you want to generate the 3D data. Pause at the point you selected. Then, click the 3D Data Generation button. Data processing takes about 30 seconds to 1 minute, and then the software displays the 3D image. You can rotate, move, and change the size of a 3D image by using the mouse and dragging the image. Point to curve. After the 3D data is displayed, you can perform 3D comparative measurements and analysis. This section explains the point to curve measurement mode. First, set the reference length by clicking the reference button. Now click the diameter button. This method lets you set the reference length by defining the cylindrical surface on the 3D data and entering its diameter. On the 3D data, specify the first and second reference points. You can adjust the selectable size by rotating the mouse wheel while holding down the Control key. When specifying the third point, confirm that the displayed cylindrical surface aligns with the 3D data before setting the third point. Then click OK. If you need to adjust the cylindrical surface, click the Add button to specify a fourth point. After the reference length input dialog appears, select a unit in millimeters, percentage, or inches, enter the reference length and click OK. A label showing the reference length will be displayed. You can move this label to any position in the 3D view by selecting it. Next, click the Measure button, followed by Point to Curve. Point to Curve is a measurement mode that measures the distance from the cylindrical surface set during the reference setup to the measurement points. By specifying measurement points on the 3D data, you can measure the depth or height from the curved surface. Deepest and highest. The deepest highest feature lets you select the area of interest and display the deepest highest values within that range, as well as the location of those points. Click the Analyze button, then click the Deepest Highest button. On the 3D data, drag to define the range for calculating the deepest and highest values. These values, along with their positions, will be displayed once you drop the button on your mouse. Additionally, by clicking in sequence on the View, 3D Color, and Contour for Curve buttons, a color gradient view will be displayed based on the height from the reference cylindrical surface. Click the Color Scale button to open the Color Adjustment dialog. You can adjust the slider to set your preferred color gradient. Once you are satisfied with the adjustments, click OK. In this display, green indicates that the distance between the reference cylindrical surface and the 3D data is close. Blue signifies that the distance is increasing as you move towards the scope's tip, while red indicates that the distance is increasing as you move away from the scope's tip. After displaying the colors, you can efficiently find the deepest and highest values by using the Deepest Highest feature. Distance and depth. This section explains the distance and depth measurement. As with Point to Curve, both measurement modes require setting the reference length. Click the Reference button. Then click the Distance button. Specify 2 reference points on the 3D data to enter the reference length, following the same procedure as in Point to Curve. Next, click the Measure button, followed by the Distance button. Specify 2 points on the 3D data, and the measurement result will be displayed. You can continue specifying additional measurement points beyond the second point to measure multiple locations. Now let's take the depth measurement. Click the Measure button, followed by the Depth button. In depth measurement, the reference plane is defined by selecting 3 points on the 3D data. By specifying a 4th point, the distance from the reference plane to the 4th point is displayed. After specifying the measurement points, click the Depth Height button to display the deepest and highest values, as in Point to Curve. Profile. This section explains the Profile feature. To create a profile, click the Analyze button, then select Profile. On the 3D data, drag and drop to specify the 2 points where you want the profile to be displayed. Once you drop the points, the profile is shown. Click the View button to switch the display mode. Whole shows the entire original 3D data, not the profile view. Cross-section shows the 3D data as a cross-section. Invert swaps the displayed side of the 3D data with its other side in the current 3D view while in cross-section view. Additionally, if a reference plane or reference cylindrical surface is set on the 3D data, the deepest and highest values relative to the reference surface, as well as their positions, will be displayed on the cross-section. In whole view, you can move the points on the cross-section to adjust the range for calculating the deepest and highest values. The yellow dashed line indicates the effective range for the calculation. Save and retrieve. With 3D Assist, you can save the 3D image. Click the Print Screen button to save the displayed image in JPEG format. Additionally, by double-clicking the right button on your mouse in the 3D view, you can copy a screenshot of the current 3D view to the Windows clipboard. For instance, you can paste this screenshot into other software applications such as Microsoft Word or Excel, which are commonly used to generate inspection reports. You can also save the image in a 3D data format by pressing the Save 3D Data button. Saved 3D data can be redisplayed in the 3D Assist software without loading the video file again. Thanks for watching.